Here we go. So many of you have already done this, but if there was a problem you didn't understand, you can just kind of fast forward to that particular problem and look at the solution. So our first problem, I guess I should write up here what the assignment was, since you weren't doing all of these. 4, 5, 7, 16, 17. Sorry, I forgot to type it in. 26, 29, a long assignment. 33, 35, 42, 43, and 49. 49 was, I'm sure, one that was probably a little challenging. All right, so number 4. What is the cosecant of theta? So here's theta, there's your opposite, your hypotenuse, here's your adjacent. So cosecant of theta is hypotenuse over opposite, because it's the reciprocal of sine. So that's going to be 6/4, or 3/2. 1 over sine theta equals cosecant theta. So these two are the same. What is the ratio of the side opposite theta to the hypotenuse? Well, that's the same thing as sine theta. What is the ratio of the hypotenuse to the side opposite of theta? Hypotenuse over opposite, that is cosecant theta. So the only one that was different was straight up sine. All the others were just another way of asking for the cosecant. Okay, in exercise. So this one you're doing 5 and 7. Evaluate the 6 trig functions. So for number 5, since we're going to do all 6, I'm going to quickly write out your 6. So then we have our cosecant, our secant, and our cotangent. Cotangent theta. All right. So these, put in my little equal signs. So where's theta? Theta's up here. So here's your hypotenuse. This is the opposite. This is the adjacent. So we have 9, we have 12, we have to find the hypotenuse. That means you're doing 9 squared. Well, actually, I'm going to show you a little trick. This is 3 times 3. This is 3 times 4. So they have a common factor of 3. The other factor is a 3, 4, 5 right triangle times 3. So this side is going to be 15. I don't know if you remember your 3, 4, 5, but that's why it's nice to know them. You don't have to do Pythagorean theorem. Okay, so the sine is opposite over hypotenuse, so that is going to be 12 over 15, which now this is actually even easier because I can just look at the reduced form. That's going to be 4/5, so that's going to be 5/4. Cosine is adjacent over hypotenuse, so that will be 3/5, and this will be 5/3. Tangent is opposite over adjacent, so that's going to be 4/3. That will be 3/4. All right. Then we have number 7. So we need to figure out what this side is. So I'm going to call, let's see, this is your adjacent, that's your opposite, that's your hypotenuse, because there's theta. So we know that a squared plus 5 squared equals 7 squared. So a squared is going to be 49 minus 25, which is 24 square root of, which is 2 rad 6. Okay, so now let's write out our 6 trig functions: sine theta, cosine theta, tangent theta, cosecant theta. It's a good way to make sure you remember your reciprocal functions, to kind of have to write it out, although I realize you did the work on big ideas. Okay, so opposite over hypotenuse is 5 over 7, so that's 7 over 5. Cosine is going to be 2 rad 6 over 7, which means this is 7 over 2 rad 6, and we are going to have to rationalize that, which I'm running out of a little bit of room here, so I'm going to pull this over. This will end up being 7 rad 6 over, because we multiply top and bottom by rad 6, 2 times 6 is 12. That's how that would reduce. Then we have tangent, which is opposite over adjacent. So that would be 5 over 2 rad 6, multiplying top and bottom. You're going to get 5 rad 6 over 12. And then cotangent, adjacent over opposite, 2 rad 6 over 5. All right? Now, we have let theta be, which one are we doing? We're doing 16 and 17. Let theta be an angle of a right triangle, evaluate the other 5 trig functions. So for number 16, they give us a triangle. They don't give us a triangle. I'm going to make a triangle. So there's theta. Cosecant, remember, is hypotenuse over the opposite. So that's 15 over, it's a really tiny 8. Oh, interesting. Okay, so I'm going to have to do some math here. Okay, so to find the adjacent side, that means the shortcut here, I don't think it's going to be one of my 225 minus 64. No, that one's not going to be pretty. I wonder if I can just do, I'm going to keep it as, this is going to be a lovely square root of 161. Sorry, it wasn't really intentional there. But what we can do, so this is number 16, right? Okay, well, I'm just going to leave it like that. 6, 7, 8, I don't know if that's 161 is divisible by anything. So we're finding all the others. Well, we're just going to still write it out. Sine, cosine, tan, cosecant, secant, cotan. All right, so we know that sine, opposite over hypotenuse, 8 over 15, and then the reciprocal. Cosine is going to be square root of 161 over 15. This is going to be 15 rad 161 over 161. How did that get to be so ugly? Oy. Okay. Tangent is opposite over adjacent, so that's going to be 8. I'm sort of rationalizing in my head, so you're just kind of, hopefully you can work these out. Cotangent is adjacent over opposite, so that one doesn't need rationalizing, which is nice. All right, that was kind of ugly. Now let's do 17. So on 17, they gave us secant theta. So let's draw a triangle. Secant, here's theta, so this is your adjacent, your opposite, your hypotenuse. So hypotenuse is 14, the adjacent is 9. 14 squared minus 9 squared. Doing our, oh my goodness, these are some ugly numbers. All right, it's okay. I like Pythagorean triples way better. Sine theta, cosine theta, and I know I just snorted, it's okay. Okay, so sine opposite, so 115 over 14, and then you would have to do that over that. Cosine is going to be 9 over 14, which is what they gave us, right? Oh, no, yeah, well, 9 over 14, because they gave us 14 over 9. And then opposite over adjacent is going to be 115 over 9, which means this is going to be 9, 115 over 115. Okay, there's your 6. Now, error analysis. Describe and correct the error finding sine theta. So sine is opposite over hypotenuse, so that should be 8 over 17. The opposite, this should be an 8. There's the error. Okay, that was really deep. All right, on this side, we are doing 20 through 26. So we're going to be doing this and all of these. Error analysis again. Describe the correct error in finding cosecant theta, given theta is acute angle of a right triangle, and cosine theta, which is adjacent over hypotenuse, would be that. So that would make this side 121. So 11 squared minus 49 is 72. 72 is square root of 72. That's, what is that, 9 times, I have, Miss Henson is texting me. 72, I shouldn't do these at night, I'm so tired. 9 times 8, no, it's 36 times 2, so this is going to be 6 rad 2. Voila. All right, so what is it? Cosecant theta is, no, cosecant theta is not that. That would be secant theta. Okay, there's their mistake. I didn't even need to do the triangle. Oh well, it's good practice. So then we're doing the next ones. Find the value. So these are your special triangles, and you should not use any calculator or anything. So this means this is 30. This is the side that is 1. This is the side that is 2. This is the side that is rad 3, opposite the 60. So if I'm trying to find x, which is opposite the 30, and I know that 2x is 9, that means that x is 9 halves, or 4.5, however you want to put it. On 22, so again, this side is 1. This is the side that is 2. So if 2x is 6, that means x is 3. That was nice, those weren't too bad. So now that's the 30 again, and this is the side on 2. So again, if 2x is 12, x is going to be 6. And again, why are these all so much alike? So 13 is on the 2x side. 2x equals 13. X is 13 halves. So you can leave it as 13 halves. I'm not sure how Big Ideas wanted your answer, or as 6.5. Now we have the 45, 45, 1, 1, 1 rad 2. So x is going to be 8. And again, 1, 1 rad 2. X is going to be 7. Whoa, those are probably the easiest special triangle problems I've ever seen. Okay, now down here, let's see. Oh gosh, I hope you didn't hear that. That was my stomach growling. We're doing 29, we're doing 31, 32, 33, and 35. All right, so these ones are just using your calculator. Make sure your calculator is in degree mode. That's important. And to do 29, what you're going to enter, because this cosecant 59 is the reciprocal of sine, so you have to actually enter it as 1 divided by sine 59. That's what you're going to do on your calculator. So 1 divided by sine 59, 1.167. I don't know what decimal place they wanted online, but that's what you would do. So on 31, we have cotangent of 6 degrees, which is the reciprocal of tangent. So 1 divided by tan 6 degrees. 1 divided by tan 6 is 9.514. And lastly, we have here 32, secant of 11. Secant is the reciprocal of cosine. So we do 1 divided by cosine 11, 1.019, 1.01, rounding up. Okay, that's just kind of how to use your calculator for when you don't have sine, cosine, tan. You do 1 divided by. There's other ways you can do things on your calculator, but I'd rather just focus on one method right now. So now we have a diagram, and they want us to solve. So this first one for 33, I am going to draw the triangle again and label things that we have. So B is 36 degrees, and A, which is down here, is 23. And they want us to solve for everything else. Oh, I see. Well, we already know that that's 90, right? So we got that one. So that means I can find A, so angle A is going to be 180 minus 90 minus 36, or really just 90 minus 36. 90 minus 36, because the two acute angles are complementary. I don't remember if you remember that. So A is, I'll write those on a different color, 54 degrees. So that's angle A is 54. Now to solve for B, that is the opposite, and we know the adjacent, which is tangent. So I know that the tangent of 36 degrees is the opposite over the adjacent. So that allows me to multiply both sides by 23. And then we go to our calculator. 23 times tangent 36 is 16.7. And then to solve for C, let's choose a different color. Hello, come back here. So to solve for C, that's your hypotenuse. So which one do we want to do? Let's try and use what we were given. That's always a good idea, not something you found just in case it was wrong. So we have the adjacent and we have a hypotenuse, which is cosine. So we know the cosine of 36 is the adjacent over the hypotenuse. When your unknown is in the denominator, these two switch positions because I can multiply both sides by C, divide by cosine. So you're going to go 23 divided by cosine 36. 23 divided by cosine 36, 28.43. And that would give you C. Oh, lovely. Ran out of room for this one. That's okay. We can squeeze it in up here. So on 35, we know that A is going to be 55 degrees and little a is 17. So right off the bat, we can figure out B, 90 minus 55, which is 35. To solve for little b, let's see, I've got, so this is as opposite of my 55 that I was given. This is the adjacent. So I could do a tangent, but you know what? I'm going to do a tangent of the 35 so that my unknown stays on top. So that's going to be b over 17, and then I'm going to multiply both sides by 17. So on the calculator, we enter 17 tan 35, 11.9. And now let's solve so that we got that one. C, anytime you have to solve for the hypotenuse, it's going to be in the denominator. So it doesn't really matter what I choose. I'm going to stick with the 17 here. So and my 35, so that's again adjacent over hypotenuse. So tangent of 35 is the adjacent over the hypotenuse. So what we're entering on our calculator is going to be 17 divided by tan 35. Sorry that I kind of ran out of room there. 24.28. is what C will be, 24.28. All right, so that is how you would solve for the right triangle and find your various reciprocal functions. Okay, so we're going to do an application problem, and since it is a right triangle, you can usually just throw down a right triangle and label it, but let's see what we have here. Katoomba Scenic Railway in Australia is the steepest railway in the world. The railway makes an angle of about 52 degrees with the ground. So you're going to have a right triangle where this is the ground and this is the actual railway. And it says the railway, so it makes an angle of 52 degrees with the ground. And it extends horizontally, which is basically the ground distance, about 458 feet. And it wants to know the height of the railway vertically. So this is what we're looking for. So this is your opposite, your adjacent. That represents tangent. So we know that the tangent of 52 degrees is the opposite over the adjacent. That allows me to multiply both sides by 458 so that we can cancel that out. And then on your calculator, you're just going to go 458 tangent 52 so that you get your height stay on. Oh my gosh, I just erased my, let's see if it, oh, there we go. I erased it on my calculator. 586 feet, about. Good enough. All right, so that was 52, because we're doing 42, 43, we're doing all three of these. 43, modeling a person whose eye level is 1.5 meters above the ground is standing 75 meters from the base of the Jinmao building in Shanghai, China. The person estimates the angle of elevation to the top of the building is about 80 degrees. What is the approximate height of the building? Okay, so taking this one all in, we know there is a building. We know there is a person standing over here. We know this person is standing 75 meters from the base of the building, and their eye level is 1.5 meters above ground. Makes sense. And the person estimates the angle of elevation to the top of the building is 80 degrees. Well, now that's from their eyesight. So this angle right here is 80 degrees. This is sort of a invisible line. So we have a little right triangle here. In other words, what we're going to do, because we have the 1.5 meters for your height, we're going to find this distance up here, and the height of the whole building will be the sum of those two. Okay, so first let's solve for x, our right triangle. So we have opposite, adjacent, which again is tangent. I know that the tangent of 80 is the opposite over the adjacent. So we multiply both sides by 75, and we find that x, 75, tangent 80, 425. We're just going to round off to the nearest meter. So when I add those together, the height of the building is going to be 426.5 meters. Okay? I guess I could have added the 0.3. It's let me see, did they say what we should round to? See, they don't say it here, so they probably tell you when you're doing big ideas, so at least you know how to do the problem. All right, now this one was a good one. A passenger in an airplane sees two towns directly to the left of the plane. So you have town 1 and town 2. What is the distance, D, so they have that labeled right here, from the airplane to the first town? So we have a right triangle right here. Now remember that the angle of depression is the same as the angle of elevation out here. You have your alternate interior angles. So this will also be 25 degrees right here. So to solve for D, I have the opposite. I have the hypotenuse, which is what I'm looking for, and that is sine. So to do part A, we're going to take the sine of 25 degrees. That equals the opposite, 25,000 feet over D. So that means that D is 25,000 feet over sine 25. And we go to our handy dandy calculadora, divided by sine 25, and we get 59,155. We talking feet here? Yes, feet. All right, awesome. Okay, so that was A. What is the horizontal distance x from the plane to the first town? So now we're looking for this. Now, this is interesting because we know 25,000, we now know D. You really could just do Pythagorean theorem on this one. It's up to you. Or you could do trig. Since this is a unit on trig, I'm going to do trig. So I've got the adjacent and the opposite, which is a tangent. So I know that the tangent of 25 is the opposite, which is 25,000 over x. And so x equals 25,000 over tan 25. So that tells me, when I go to my handy dandy calculadora, tan 25, this is going to be 53,612.67 feet. I don't know what decimals they want, so I'm just going to give them some. Then part C, what is the distance y between the two towns? Aha. So in order to do that one, we need to find, we're going to have to deal with this triangle. Actually, you know what? I'm going to do it a different way because you guys know your law of sines and law of cosines, right? Yes, you do. Do I have enough information though? I know that and I know that. Oh, poo, I can't do law sines. I thought I would, but I don't have enough information. That's okay. So we do know that this is, hello, where's my, we know this is 25 degrees here. We know that this is going to be 15 degrees because that angle will match that angle. And we know that this is 53612.67. We know this is 59155. We know this is 25,000. And we're trying to find that. So what I am going to do is think about this for a minute. I do have enough. I am going to do a law of sines. Awesome. Okay, I like this. So if this is 25 right here, and these two angles right here make up a line. We know a line is 180. So 180 minus 25, this is going to be 155, which means I know this angle because it's 180 minus 155 minus 15. So that's an angle of 10 degrees right there. This is awesome. So I have a pairing. I have this angle opposite this side. So I know that the sine of 15 is to 59155 as, let me move my little C here, as the side we're looking for is to the sine of 10 degrees. I can do the law of sines. This is awesome. I'm so glad we did. It's so much easier than I think what they wanted. So I'm going to multiply both sides by sine 10 to cancel it. And then we can go 59155 sine 10, close parenthesis, divided by sine 15. And we get that y equals 39688. Yeah, 0.57. I don't know how many decimals they want, so we'll put it in there. Okay, so what I did was, it was nice. Using right over here, I could just use right triangle trig. Over here, since I now have a pairing of a side and an opposite angle, I can use my law of sines.